Good evening everyone, good evening. I welcome you all again to VJ Enthuse and I hope you guys are doing great, having a good time. So people, before starting the session, you can let me know in the chats if I'm audible and visible to everyone. Hello Chitra, hi Sambhav, hello Ashwarya, hello Abhivya, welcome back, hello Rinda, hi Nivedita, hi Roshni, hi Trisha. Welcome back people, welcome back. Just let me know in the chats if I'm audible and visible to everyone. Give me some green signal from the chat box. Yeah? I'm doing good guys, I'm doing good. Well, my day was good. Yeah? How was your day? I'm doing good, Aisha, how are you? That's perfect, Chitra, that's perfect. Alright, so people, as you all must be knowing tonight, we are going to start the new chapter from your class 11th chemistry, and the name of the chapter is going to be Redox Reactions, right? One of the important chapters from your class 11th chemistry, yeah? So before starting the session, the ones who are new to the channel, let me introduce myself. Well people, my name is Wassim and I'm your chemistry master teacher writer on this JEE Enthuse channel, yeah? The ones who have not liked the video yet, please do like the video, share the video with your friends, do subscribe to the channel, and do not forget to hit the bell icon so that you get the notification of every single session which I'll be taking live on this JEE Enthuse channel. Yes, Nimalan, this is the first lecture of this chapter, right? This is going to be the first session of this Redox Reaction chapter, okay? So the ones who have just joined in, please do like the video, share the video with your friends, and do subscribe to the channel as well, okay? Perfect. Anil, I'm doing good. How are you? Wonderful guys. So you can first of all let me know in the chats if you guys are super duper excited for the new chapter which I'm going to start now, and the name of the chapter is going to be Redox Reactions, right? Just let me know in the chats if you people are super duper excited about this. Yes, Trisha, you can follow this chapter without knowing the atomic structure. Yes, you can follow this chapter. Perfect. Yes, Gaurav, that's completed. That's completed, bro. Okay, so someone is asking, what about the next chapter? Next chapter is going to be chemical bonding or chemical equilibrium, right? Or thermodynamics. We'll see after this chapter, okay? Perfect. So without wasting a lot of time, let's get started with the first topic which I'm going to cover in tonight's discussion. And the name of the topic is something which we call as oxidation state, right? The point is, how do we define the term oxidation state? One of the most important topics, right? Okay. Well, if you understand this concept of oxidation state properly, so you can understand the concept of equivalent mass properly. And once you understand the concept of equivalent mass properly, you will understand the concept of normality. And once you understand the concept of normality, you'll understand the concept of equivalence as well, right? And then at the end, you'll be understanding the titrations as well, which involves redox titration, acid-base titration, etc., right? Okay, all those things I'll be covering in this chapter, right? So without wasting a lot of time, let's get started with something called as oxidation state. The point is, how do we define this term oxidation state? Understand. See guys, oxidation state, it is basically the charge present on an atom, in a given compound, or you can say the charge present on an element in a given compound is something which we call as oxidation state. What exactly that means? Remember the definition first. The charge present on an element, and the charge can be real or virtual, right? What is real charge? What is virtual charge? After few minutes, you'll get the clear-cut idea of this as well, okay? First thing, the charge present on an element which can be real or virtual in a given compound is something which we call as oxidation state of a particular element, right? For example, have a look guys. All of you must have heard about something called as ionic compounds, right? You all must have heard about something called as ionic compounds. The example of the ionic compound which I'm taking over here, that's NaCl, right? This is the typical example of the ionic compound, which is NaCl, yeah? If I talk about this NaCl, people, how do I define the oxidation state of sodium? Oxidation state of sodium in this compound will be the charge present on sodium in NaCl. That's something which I call as oxidation state of sodium over here. Similarly, the charge present on chlorine over here in this compound is something which I'll be calling as oxidation state of chlorine, right? Yes. Now exactly, let's see Let's see what is going to be the charge present on sodium and what is going to be the charge present on chlorine. And whatever is going to be the charge present on sodium or chlorine, that is actually going to be their respective oxidation states, yeah? Okay, now people understand. Let's exactly see how this NaCl gets formed, right? This NaCl, it contains sodium and chlorine. As you all must be knowing, sodium is the common example of a typical metal. This chlorine is the example of the typical non-metal, right? Okay, so metal has got the tendency to lose electrons, as you all must be familiar with, and non-metal, it has got the strong tendency to gain electrons, yeah? So how this NaCl compound got formed? So basically, sodium, which is the typical metal, right, which is highly electropositive in nature, right? This sodium has got only one electron in its outermost shell, so it easily loses that one electron and gets converted into Na positive. Now this one electron which is completely lost by this sodium, this one electron will be completely gained by the chlorine, and this chlorine will be getting converted into Cl negative over here, right? Okay, so first thing, sodium lost one electron completely and chlorine gained this one electron completely, due to which you got Na positive and Cl negative, right? So basically I got two charged species, one is Na positive and one is Cl negative, right? So I got two charged species, one carrying the positive charge, one carrying the negative charge. Okay, so can I say there'll be force of attraction between these two species? And this force of attraction between this cation and anion is something which I call as ionic bond, or you call it as the electrovalent bond. You call it as the electrovalent bond, right? Okay, so people, this ionic bond or electrovalent bond, it's formed by the complete transfer of electrons, So sodium first lost one electron completely, then it got converted into Na positive, right? Chlorine gained this one electron completely, then it got converted into Cl negative. Then there will be force of attraction between these two ions, and that force of attraction is something which I call as ionic bond, or you call it as the electrovalent bond, right? Okay. Now people, if I ask you, in NaCl, can I say sodium is actually present in the form of Na positive, and in NaCl, chlorine is actually present in the form of Cl negative, right? There is attraction between them, which makes the formation of NaCl over here. So now, since you got to know what is the charge present on sodium, what is the charge present on chlorine, few minutes back I defined the oxidation state. Oxidation state is nothing, that is the charge present on an element in a given compound. So what is the charge present on sodium over here? It's +1, right? So I'll say +1 is the oxidation state of sodium right here. What is the charge present on chlorine over here? It is -1. So I'll say -1 is the oxidation state of chlorine in this compound. I'm sure it's clear to everyone. And people, at the same time, if you'll just understand one more thing. In case of ionic compounds, whatever will be the charges present on the species, these are going to be the real charges, these are going to be the actual charges, because in case of ionic compounds, there is complete transfer of electrons, I must say, right? Okay, sodium, on losing one electron completely, got 1 unit of positive charge, right? Chlorine, on gaining this one electron completely, got 1 unit of negative charge, right? So basically these are the real charges present on sodium and chlorine over here, right? So in case of any ionic compound, whatever is going to be the charge present on the species, that charge is going to be the actual charge, that's going to be the real charge, right? Now similarly, if I take, yes Chitra, it is live, yes, it's live. Okay, now people, similarly, if I talk about something called as covalent compound, right? If I take the case of any covalent compound, let me take the case of the covalent compound. The common example of the covalent compound I'm taking as water, as you all must be knowing. People, you all must be familiar with the structure of water, which is H2O, like this bent structure, as you all must be knowing, right? Now in your periodic table, which is the most electronegative element? Fluorine, followed by oxygen, followed by nitrogen. I hope you know this. Fluorine is the most electronegative element, followed by what? Followed by oxygen, and then followed by nitrogen, right? So fluorine has got the most tendency, it has got the highest tendency to attract the bonded pair of electron towards itself, right? Fluorine is highly electronegative. It has got the strongest tendency among all the elements to attract the bonded pair of electron towards itself, right? You must be knowing this, correct? Now we will have a look. This bond between oxygen and hydrogen, right? It's a single bond, right? Single bond is formed by 2 electrons. One is given by oxygen, one is given by hydrogen. This bond is covalent in nature. So there should be mutual sharing of electrons. There should be mutual sharing of electrons, right? So I'm expecting this bond pair of electron, I'm expecting to be at the center. But what happens exactly? We know oxygen being more electronegative, it will attract this bonded pair of electron towards itself, right? Due to which this oxygen gets slight negative charge and hydrogen gets slight positive charge, right? Similarly, if I talk about this bond is again formed by two electrons, one given by hydrogen and one given by oxygen. Since it's again a covalent bond, so I'm expecting this bond pair of electron to be at the center. But what happens exactly? Oxygen being more electronegative, it is going to attract this bonded pair of electron towards itself, due to which again it gets delta negative and this hydrogen gets delta positive, right? So what is the charge present on this hydrogen over here? It's delta positive. What is the charge present on this hydrogen over here? It's delta positive. What is the charge present on this oxygen over here? It's going to be minus times 2 delta. Minus times 2 delta, right? Okay. If I'll ask you, is this hydrogen having complete real 1 unit of positive charge? No, this hydrogen won't be having the actual 1 unit of positive charge. Hydrogen can only get 1 unit of positive charge. Hydrogen can only get the actual 1 unit of positive charge if it loses its electron completely. But hydrogen is not losing its electron completely right here. Okay, it is just the bond pair slightly gets shifted towards oxygen, but that does not mean the hydrogen loses its electron completely, right? Similarly, if I'll ask you, is this minus 2 going to be the actual charge present on oxygen? No. When can oxygen get minus 2 charge? Oxygen can only get minus 2 charge if it gains 2 electrons completely. But this oxygen is not gaining 2 electrons completely, right? It is just there is shifting of electron pair from here as well as here, right? Due to which it gets minus 2 delta charge over here. So if I'll ask you, are these charges which are present on these atoms, are these actual charges, real charges? No, these are not the real charges. These are absolutely the virtual charges, right? They seem to be present on the atoms. Due to the electronegativity differences, right? Otherwise, these are not the actual charges. Right? I'm sure it's clear to everyone. Yeah? Similarly, guys, if you talk about NH3, let me take the case of NH3 as well. Yeah? See, if I talk about this bond between nitrogen and hydrogen, I'm expecting the bond pair to be at the center, but nitrogen being more electronegative, so nitrogen will attract this bonded pair of electron towards itself, due to which it gets delta negative, this gets delta positive. Similarly, due to this bond pair, nitrogen gets delta negative, hydrogen gets delta positive. Similarly, due to this bond pair, it gets delta positive, this one gets delta negative, right? Okay, so what is the net charge present on this hydrogen over here? It's delta positive. What about this hydrogen? Delta positive. What about this hydrogen? Delta positive. What about this nitrogen? It's going to be minus 3 delta negative. Minus 3 delta negative, right? Okay. I mean minus 3 delta, sorry. Minus 3 delta over here. If I'll ask you, are these going to be the actual charges? These are not the actual charges, right? These would have been the actual charges when there would have been the complete shift of electrons. I mean complete shift of electrons, right? It would have been exactly plus 1 unit of positive charge when this hydrogen would have lost 1 electron completely. But it's not losing its electron completely. It is just the electron pair slightly gets shifted towards nitrogen. That's it, right? So if I'll ask you, are these actual charges? No, these are not the actual charges. Are these real charges? No, these are not the real charges. Are these virtual charges? Yes, these are virtual charges. They seem to be present on the atoms. Due to what? Due to electronegativity differences, right? I'm sure it's clear to everyone, right, people? Okay, so I hope you got the concept of what oxidation state is all about. Again, I'm repeating the same definition. The charge present on the element, which can be real, as in case of ionic compounds, virtual, as in case of covalent compounds, right? The charge present on an element, right, which can be real or virtual in a given compound, is something which we call as oxidation state, right? I'm sure it's clear to everyone, right? And we will do remember one thing. In case of ionic compounds, mark this statement, in case of ionic compounds, due to the complete transfer of electrons, the charge is real. But in case of covalent compounds, the charges are not real, the charges are virtual, right? These are the virtual charges. These are not the actual charges, these are the virtual charges, yeah? Right, people? Thank you, Nitish. I'm sure every single thing is clear till here. Yeah, people? So you got to know the concept of what oxidation state is all about. Now the point is, how do we calculate this oxidation state? There are certain rules which I want you guys to remember. After remembering those rules, you can easily calculate oxidation state of any element in a given compound. There are some 6 to 7 rules which I want you guys to remember properly. After remembering those rules, you can calculate the oxidation states of different elements in a given compound, right? What are those rules all about? Have a look exactly. Just give me a second. See guys, the first rule, the oxidation state of an element in its standard state is taken to be 0. Now the first point is, what is the standard state of an element? That state of an element in which the element exists in nature. That state of the element in which the element exists in nature, that's something which we call as standard state of a particular element. For example, oxygen in nature exists in the form of O2 gas, right? Nitrogen in nature exists in the form of N2 gas. Fluorine in nature exists in the form of F2 gas, right? Similarly, iron, it exists in atomic form, Fe solid. Zinc exists in atomic form, zinc solid, right? Okay, so that state in which the element actually exists in nature, that's something which we call a standard state. And remember, whenever the element will be present in its standard state, its oxidation state will be taken as 0. This is the first rule, right? So I'll say over here, oxidation state of oxygen is 0, oxygen state of nitrogen is 0, this will be 0, this will be 0, this will be 0. As simple as that, right? Okay, why it happens exactly? Let me take the case of F2. This is F2 for example. This is F2 molecule, right? This is F2 molecule. Okay. I'm saying the oxidation state of fluorine in F2 is 0, right? That means the charge present on fluorine in F2 is 0, right? How come it's possible? See guys, this is a covalent bond between fluorine and fluorine, right? Right? So this covalent bond is formed by 2 electrons, one given by this fluorine, one given by this fluorine, right? So this electron pair will be exactly at the center. Why it's going to be at the center? Because the tendency with which this fluorine attracts this bonded pair of electron towards itself, this fluorine attracts the same bonded pair of electron towards itself with the same tendency, right? Because on both the sides you have got fluorine. The tendency with which this fluorine will be attracting the bonded pair of electron towards itself. With the same tendency, this fluorine will be attracting the same bonded pair of electron towards itself, due to which there won't be any shifting of electron pair. There won't be any shifting of electron pair. If there is no shifting of electron pair, there will be no contribution of this bond, there will be no contribution of this bond towards the charges present on fluorine, I must say, right? That's why I say oxidation state of fluorine in case of F2 is going to be simply 0. I'm sure it's clear to everyone. Yeah? Right, people? Guys, I'm not ignoring anyone. It is just, I don't keep a look on the chats. When I start teaching, I just teach. Yeah? Okay? I'm sure this first rule is clear to everyone. So whenever the element exists, whenever the element will be present in its standard state, you call this standard state as the native state as well. Let me tell you one more thing. You call the standard state of the element as the native state as well, right? And native state is also called as the elemental state. It is also called as the elemental state. So remember, whenever the element will be present in its native state, standard state or elemental state, its oxidation state is to be taken as 0. Point number 1. This is rule number 1, right? Now rule number 2. Rule number 2. Remember, if we talk about alkali metals, group first elements are called as alkali metals. All the alkali metals, be it lithium, sodium, potassium, rubidium, cesium, right? All these group first elements, they have got just one electron in their outermost shell. So these group first elements, they easily lose that one electron. And show +1 oxidation state, right? So remember from now onwards, your alkali metals, your group first elements, they are always going to show the +1 oxidation state, right? Be it lithium, sodium, potassium, rubidium, cesium or whatever, yeah? Right, people? Similarly, if I talk about the alkaline earth metals, these are the group second elements, which starts from beryllium, magnesium, calcium, strontium, barium, radium, right? Okay, these are group second elements. And group second elements, which are what we call as alkaline earth metals, right? Which are what we call as alkaline earth metals. They have got 2 electrons in their outermost shell. So they easily lose those 2 electrons and they show the oxidation state of +2, right? Okay, so remember, your alkali metals, which are group first elements, they show the oxidation state of what? They show the oxidation state of +1. Your alkaline earth metals, they show the oxidation state of +2 always. This is one more rule which I want you guys to remember. Now the third rule. What is that? The oxidation state of hydrogen is generally taken as +1 when attached to more electronegative element than itself. Whenever hydrogen will be attached to a more electronegative element than itself. Whenever a hydrogen will be attached to a more electronegative element than itself, then the oxidation state of hydrogen will be taken as +1. Then the oxidation state of hydrogen will be taken as +1, right? Okay. See people exactly how it's going to be +1. If I take the case of HCl, let me take the case of HCl, correct? Right? See exactly guys. Chlorine being more electronegative. If chlorine is more electronegative, then this bond pair of electron will be shifted towards chlorine, right? Due to which chlorine gets delta negative, hydrogen gets delta positive, correct? Are these real charges or virtual charges? These are virtual charges right now, right? Now people, at the same time, if I'll ask you what is the oxidation state, now we know these are virtual charges. So I'll be representing it as +1, I'll be representing it as -1. But you should know this is not the real charge, this is the virtual charge, right? Delta is understood now, right? Okay, so remember, whenever hydrogen will be attached to a more electronegative element, like chlorine, oxygen, fluorine, then itself, okay, right? At that time, hydrogen shows the +1 oxidation state. Okay, this is one more rule. Next rule, when the same hydrogen will be attached to less electronegative element than itself. When the same hydrogen atom is attached to a less electronegative element than itself, right? The oxidation state of hydrogen will be taken as -1. For example, if I take the case of sodium hydride or magnesium hydride, NaHMgH, okay? Remember, the electronegativity of hydrogen is definitely more than that of sodium. The electronegativity of hydrogen is definitely more than that of magnesium, due to which hydrogen over here shows -1, over here again it shows -1, right? Whenever hydrogen will be attached to a less electronegative element than itself, right? Okay, at that time, the oxidation state of hydrogen will be taken as -1, as simple as that. Yeah, this was one more rule. Moving on to one more rule. The oxidation state of oxygen, talking about oxygen now, the oxidation state of oxygen is generally taken as -2. I'm using the term generally, okay? The oxidation state of oxygen is generally taken as -2 when oxygen is attached to a least electronegative element than itself, right? The oxidation state of oxygen is generally taken as -2 when it's attached to less electronegative element than itself. For example, have a look. If I talk about water, let me take the case of water. Okay, in case of water, oxygen is attached to less electronegative element, hydrogen, right? Due to which, if I talk about this bond, it is going to be what? It's going to be plus delta, this is going to be minus delta. Oxygen being more electronegative, so this is minus delta, this plus delta. What is the net charge present on oxygen? You will say -2, right? -2 delta. So if I'll ask you what is the oxidation state of oxygen, right here it's going to be -2, right? So whenever oxygen will be attached to less electronegative element than itself, the oxidation state of oxygen is definitely going to be taken as -2 generally, okay? Similarly, if you take the case of sodium, sodium oxide, Na2, oxidation state of oxygen is going to be -2. Magnesium oxide, oxidation state of oxygen is going to be -2. In all the cases over here, oxygen is attached to less electronegative element than itself, right? Okay, I'm sure again it's clear to everyone, right people? Similarly, moving on to one more. I told you generally whenever oxygen will be attached to a less electronegative element than itself, the oxidation state of oxygen is going to be taken as -2 generally, right? But in case of peroxides, what are peroxides? Okay, before talking about peroxides, let me tell you, whenever you see one oxygen linked to another oxygen by means of a single bond, whenever you see one oxygen linked to another oxygen by means of a single bond, we call this linkage as the peroxide linkage, right? Let me not write it over here. See, this is oxygen attached to one more oxygen by means of a single bond, right? So I'll be calling this linkage as the peroxide linkage. I'll be calling this linkage as the peroxide linkage, and any compound which contains the peroxide linkage, that's something which we call as peroxide. That's something which we call as peroxide, right? That's something which we call as peroxide, right? Right, guys? Okay, now guys, in case of peroxides, generally oxygen shows the oxidation state of -1. I'm using the term generally. In case of peroxides, generally oxygen shows the oxidation state of -1. For example, if I talk about hydrogen peroxide, H2O2, you all must be familiar with the structure of H2O2 generally, okay? That's something which you would have studied in your class 9, 10th as well, right? Okay. Now people, understand. If I talk about oxygen and hydrogen, which one is more electronegative? Oxygen, due to which this bond pair will be getting shifted towards oxygen. Oxygen gets delta negative, hydrogen gets delta positive, right? Now I'm not using delta negative, delta positive. I'll be simply using +1, -1, right? Now it's understood. Delta is understood, right? Okay. Now oxygen being more electronegative, so oxygen will attract the bonded pair of electron towards itself. So -1, this hydrogen will show +1. Similarly, if I talk about this bond, oxygen being more electronegative, so this will be -1, +1, right? Will there be any contribution of this bond towards the charge present on this oxygen and this oxygen? No way. Because the bonded pair of electron which is over here, that will be simultaneously attracted by this oxygen as well as this oxygen towards itself, due to which there will be no shifting of this electron pair. So this electron pair will have no contribution on the charges present on either of the oxygens, right? So remember, whenever you see in a compound oxygen linked to another oxygen by means of a single bond, the oxidation state of oxygen is generally taken to be -1, right? As in case of hydrogen peroxide. This was one more rule. Similarly, if I talk about superoxides, whenever you see oxygen present in the form of O2 negative, whenever you see oxygen present in the form of O2 negative, we call it as a superoxide. And in case of superoxides, the charge present on one oxygen is -1/2, or I can say the oxidation state of oxygen is going to be -1/2 in case of superoxides. You can check it out as well. See, how do we define oxygen state? How do we define oxidation state? Oxidation state is the charge present on an element in a given compound, right? Okay. So if I define the oxidation state of oxygen in this superoxide, I need to exactly see what is the charge present on one oxygen over here. And the charge present on one oxygen atom over here in this compound will be called as the oxidation state of oxygen. Oxidation state is defined for, oxygen state is defined per atom, right? Per atom. For a single atom it's defined, right? Now guys, see. As you can see in this compound, two oxygen atoms are carrying the charge of -1, right? So one oxygen atom will be carrying the charge of -1/2, and the charge present on one oxygen atom in this compound is something which I call as the oxidation state of what? Oxygen. In case of what? In case of superoxides, right? So remember, in case of normal oxides, wherein oxygen will be linked with the less electronegative elements than itself, its oxidation state generally will be taken as -2. But whenever it will be forming the peroxides, its oxidation state generally is going to be -1. And whenever it forms superoxides, its oxidation state is generally going to be -1/2. Yeah? Okay? Right, people? Thank you, Partha. Thank you. Now people, there are a few more things. If I talk about oxyfluorides are the only compounds wherein oxygen shows the positive oxidation state, right? Oxyfluorides are only compounds wherein oxygen shows the positive oxidation state. Okay, for example, if I take the case of OF2, this is the structure of OF2. Fluorine being more electronegative than that of oxygen, fluorine will attract the bonded pair of electron towards itself, so -1, this will be +1. Due to this bond, it's going to be -1, this is going to be +1. What is the net charge present on this oxygen over here? You'll say +2. So +2 is the oxidation state of oxygen in this compound, right? Okay. Similarly, if you talk about O2F2, this is the structure of O2F2 as you all must be familiar with. This is the structure of O2F2, right? Now people, talking about this single bond between oxygen and fluorine. Fluorine being more electronegative, so -1, oxygen +1. Fluorine being more electronegative, -1, +1. There's a peroxide linkage over here, single bonded linkage between oxygen and oxygen. So there'll be no contribution of this bond towards the charges on these two oxygen atoms. So if I'll ask you, what is the net charge present on this oxygen? You'll say +1. What is the net charge present on this oxygen? You'll say +1, right? And the charge present on an atom in a given compound is what we call as oxidation state. So if I'll ask you, what is the oxidation state of oxygen over here? You need to see on one atom of oxygen, what is the charge present? And on one atom of oxygen, the charge present is +1. So +1 is going to be the oxidation state of oxygen in case of your O2F2. Similarly, +2 is going to be the oxidation state of oxygen in case of what? In case of OF2. I'm sure this is again clear to everyone. Right, people? Just let me know in the charts if every single thing is clear so that I can move on to a few more concepts, few more important concepts. Right? And the ones who have not liked the video yet, please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well, right? Now guys, let's move on. Few more rules which you need to remember. The oxidation state of halogen is generally taken to be -1. The oxidation state of halogen is generally taken to be -1 when the halogen will be attached to less electronegative element than itself. Halogen means group 17 elements: fluorine, chlorine, bromine, iodine, astatine, right? This is something which we call as halogens, right? And halogens, when they'll be attached to less electronegative element than itself, the oxidation state of halogen will be generally taken as -1, right? Because halogens have got 7 electrons in their last shell, they just need 1 electron to complete their octet. So they gain that 1 electron, right? Due to which they show -1 oxidation state. If I take the examples, if I talk about HCl, guys, if I talk about HCl, this is HCl, right? Chlorine being more electronegative, so -1 + 1. Chlorine is the halogen, it is attached to less electronegative element, so oxidation state of chlorine right here is going to be -1. If I talk about HBr, this is HBr for example, bromine being more electronegative than hydrogen, so bromine will show -1, hydrogen will show +1. So this halogen shows the oxidation state of -1 again over here. So remember, whenever halogen will be attached with the element which is going to be less electronegative element than that of your halogen, right? Halogen at that time shows the -1 oxidation state. I'm sure it's clear to everyone, right? Similarly, guys, few more important things. When halogen is attached to more electronegative element, whenever halogen will be attached to more electronegative element, it will be showing positive oxidation states. It will be showing positive oxidation states. For example, if I take the Cl2O example, this is the Cl2O example. Oxygen being more electronegative than that of chlorine, so oxygen will show -1, chlorine will show +1. Oxygen again being more electronegative than that of chlorine, so -1, this is +1. What is the charge present on this oxygen? Over here it's -2. What is the charge present on this chlorine right here? It's +1. What is the charge present on this chlorine over here? It's +1. Chlorine is our halogen basically, and the oxidation state of this halogen over here it's +1, right? As I told you, whenever the halogen is attached to more electronegative element than itself, like oxygen, right? Its oxidation state will be taken as +1. I mean positive oxidation state generally, right? Okay. Similarly, let me take few more cases. Let's talk about ClF3. Let me take the rough structure of ClF3. This is the rough structure of ClF3, right? This is the rough structure of ClF3, correct? Now guys, understand. First thing, fluorine being more electronegative than that of chlorine, so fluorine will show -1, chlorine will show +1. Fluorine will show -1, chlorine will show +1. This fluorine will show -1, chlorine will show +1. So chlorine, this halogen which I'm talking about in particular right now, okay, it is again showing the positive oxidation state, right? So whenever your halogen will be attached to more electronegative element than itself, the oxidation state of halogen can be positive as well, yeah? Right? I'm sure all the things are clear till here. I'm moving on directly to few more concepts, right? Similarly, in case of IF7, if I ask you what is going to be the oxidation state of iodine in this compound, you'll say +7 is the oxidation state. +7 is the oxidation state of iodine in this compound, right? Okay. Now, people, there is something called as radicals. What are radicals all about? Radicals are basically the atoms or group of atoms. Radicals are basically the atoms or group of atoms which carry certain charge on them, right? Atoms or group of atoms carrying any charge on them are something which we call as radicals. And radicals are actually considered as a single unit. And whatever is going to be the charge present on the radical, that is going to be considered as the oxidation state of the radical. For example, if I talk about Na positive, atom carrying the charge, Cl negative, atom carrying the charge, PO4 tri negative, group of atoms carrying the charge, SO4 di negative, group of atoms carrying the charge, Cn negative, group of atoms carrying the charge, Nc negative, group of atoms carrying the charge, C2O4 di negative, group of atoms carrying the charge. All are the examples of the radicals, right? So what is a radical? First of all, it is the atom or group of atoms carrying charge on them, right? And whatever is going to be the charge present on radical, that is going to be called as the oxidation state of that radical. So if I'll ask you what is the oxidation state of this sodium right here, you'll say +1. If I'll ask you what is the oxidation state of this chlorine right here, you'll say -1. If I'll ask you what is the oxidation state of this PO4, because it is a group of atoms, it's a radical. Radical will be considered as a single unit. So I'll say oxidation state of this PO4 right here is going to be -3. Oxidation state right here is going to be -2. Again, it's going to be considered as a single unit. Again, it's going to be considered as a single unit, right? -1. Again, it's going to be considered as a single unit, -1. Again, it's going to be considered as a single unit, so -2, right? So radicals are basically the atoms or group of atoms carrying any charge on them, right? And at the same time, do remember, these radicals, these are considered as the single unit, and whatever is going to be the charge present on the radical, that's going to be called the oxidation state of the radical, right? Okay, I'm sure this concept is also clear to you. So people, do remember these examples properly, okay? See, if I talk about the halides, F negative, Cl negative, Br negative, I negative, all these are radicals. Charge present on them, -1, so -1 is the oxidation state of any one of these. O di-negative, charge is -2, -2 is the oxidation state. N tri-negative, charge -3, -3 is the oxidation state. P tri-negative, -3 oxidation state. S di-negative, -2 oxidation state, right? Similarly, OH negative, it's a group of atoms carrying charge. Group of atoms carrying charge, right? It's a radical, and this radical will be considered as a single unit. The charge present on this radical is -1, so -1 is going to be the oxidation state of this radical over here, right? Similarly, if I talk about Cn negative, -1, Nc negative, -1, SO4 di negative, -2, SO3 di negative, -2, right? All these are basically the common examples of the radicals which you will find in this chapter. PO4 tri negative, -3, PO3 tri negative, -3, oxalate ion, -2, S2O3 di negative, -2, S4O6 di negative, -2, right? So again, I'm repeating the same thing. Radicals are considered as the single units, right? And whatever will be the charge present on the radical, that's going to be the oxidation state of that radical, because radicals are considered as the single units, right? Similarly, these are few more examples. You can take a note of these examples as well, right? Now, people, the important statement which I want you guys to note, right? Important statement which I want you guys to note and use properly. Use properly. What is that important statement? This is the important statement. The sum of oxidation states, of all the elements present in a molecule is equal to the net charge present on it, right? The sum of the oxidation states of different elements present in the molecule is equal to the net charge present on the molecule, right? How do we understand this? What all things can we depict from this? Before that, let me have some water, right? People, you can let me know in the chat. Is everything clear till here? Let me know till then in the chats. Yeah? Perfect. Perfect. Okay. Perfect, guys. Now exactly, let me make you understand the statement which I mentioned over here. What was that? The statement was, the sum of the charges present on the elements in a given molecule is equal to the net charge present on the molecule, right? Now understand. See, I'm making you understand this concept in the form of the questions, right? Calculate the oxidation state of the green colored atom. You need to calculate the oxidation state of chromium right here, right? Okay. You need to calculate the oxidation state of chromium right here. Let's assume the oxidation state of chromium over here is X. How many chromium atoms do we have? We have got some 2 chromium atoms over here. Oxidation state of oxygen is taken to be -2 generally. How many oxygen atoms do we have? 7 oxygen atoms. What is the net charge present on this molecule? You'll say -2. Well, if you calculate it, you get the value of X as what? You get the value of X as +6. So I'll say +6 is the oxidation state of chromium right here in this compound. That's something which I was supposed to calculate, right? Similarly, if I ask you, what is the oxidation state of sulfur over here? Let's assume the oxidation state of sulfur is X, but I have got some 2 sulfur atoms, so multiplied by 2. Oxidation state of oxygen is taken to be -2, right? But there are 3 oxygen atoms, so multiplied by 3 is equal to net charge present on this is -2, right? So if you calculate it, you get the value of X as +2 over here. That +2 will be the charge present on one sulfur atom. That +2 is going to be called as the oxidation state of sulfur over here, right? Kunal, I'm doing great. How are you? Okay, if I talk about the oxidation state of nitrogen over here, let's assume the oxidation state of nitrogen is X, right? Hydrogen normally shows +1 oxygen state. How many hydrogens do we have? 4 hydrogens. What is the net charge present on it? +1. So if you solve it, you get the value of X as -3. So I'll say -3 is the oxidation state of nitrogen over here. -3 is the charge present on nitrogen atom over here, which is what I call as oxidation state of nitrogen in this compound, right? Similarly, if I take the case of chlorine over here, let's assume its oxidation state is X, right? Oxidation state of oxygen is -2. So there are 4 oxygen atoms. Net charge present on it is -1. If you solve it, you get the value of X as +7. So +7 is the oxidation state of chlorine right here. Yes. Similarly, if you look at the oxidation state of chromium right here, let's assume the oxidation state of chromium is X, right? Okay, the charge present on oxygen is -2. There are 4 oxygen atoms, right? And the net charge present on the molecule is -2. So the value of X over here comes out to be +6. So +6 is the oxidation state of chromium in this compound over here, right? I'm sure everything is clear till here. Yeah, absolutely, guys. Let me take a few more examples so that you master this concept, right? Okay, if I talk about Fe2O3, right? I'm talking about Fe2O3. I need to calculate the oxidation state of iron. Let's assume the oxidation state of iron is X. How many iron atoms do we have? We have got some 2 iron atoms, right? Oxidation state of oxygen, you all must be knowing, -2. How many oxygens do we have? 3. Net charge present on the molecule is 0. When you solve this, you get the value of X as +3, and that +3 is basically the charge present on iron over here, right? Similarly, if you look at the oxidation state of this iron over here, let's assume its oxidation state is X, and there are some 3 iron atoms, right? Let's assume the oxidation state of oxygen is -2, and there are some 4 oxygen atoms. Net charge is 0, so the value of X comes out to be +8/3. So +8/3 is basically the oxidation state of iron over here, right? Similarly, if I want you guys to calculate the oxidation state of iron over here in this compound, right? See, this iron is attached with Cn. Cn, few minutes back, it exists in the form of Cn negative, right? Okay. Cn negative is basically a radical, and radicals are considered as a single units, and whatever will be the charge present on the radical, that's going to be taken the oxidation state of that radical, right? Now have a look. Let's assume the oxidation state of iron is X. Let's assume the oxidation state of Cn is -1. How many Cn do we have? 6 Cn. Net charge -3. So solve X. X you'll be getting as +3 right here. This CO, carbonyl, CO, it does not have any charge on it. If it does not have any charge on it, so the oxidation state of nickel over here is going to be 0, right? Okay. Similarly, if you calculate the oxidation state of sulfur in this one, right? Well, the oxidation state of hydrogen is +1. And how many hydrogen atoms do we have? 2 hydrogen atoms. Let's assume the oxidation state of sulfur is X, right? Let's assume the oxidation state of oxygen is -2. How many oxygens do we have? 4. The net charge is 0. So you can calculate the value of X as +6 over here. So +6 is basically the oxidation state of sulfur in this compound. I'm sure every single thing is clear till here, right? Okay. Yeah. So just let me know in the chats if it is clear to everyone. Let me know fast in the chats, guys, so that I can move on to a few more examples, right? Which are going to make a few more concepts clear to you. Yeah? How 0 in the fourth one? How 0 in the fourth one? This CO, it does not have any charge on it. It does not have any charge on it, right? Remember it. It does not have any charge on it. Okay? If it does not have any charge on it, it's neutral basically. It's a neutral species. Okay, so if it does not have any charge on it, that simply says the oxidation state of nickel is going to be 0, right? Yeah. Last one is simple. Let's assume the oxidation state of hydrogen is +1 first of all. 2 hydrogen atoms multiplied by 2. Oxidation state of sulfur is X. Oxidation state of oxygen is -2. So there are 4 oxygen atoms. Net charge present on the molecule is 0. So that's how you get the value of X as +6. That's all. Yeah, that's all. These are the 2 more species which you need to remember, right? Okay, understand, guys? You need to calculate the oxidation state of this nitrogen and this nitrogen. Well, let me tell you, in case of your NH4NO2, this NH4NO2, it actually exists as NH4 positive and NO2 negative. It exists in the form of NH4 positive and NO2 negative, right? So I need to calculate the oxidation state of this nitrogen and this nitrogen, okay? What about the oxidation state of this nitrogen? Let's assume it as the X. Oxidation state of hydrogen, you'll say as +1. There are some 4 hydrogen atoms. Net charge present over here is +1. So the value of X will come out to be -3. So -3 is basically the oxidation state of this nitrogen, right? What about the oxidation state of this nitrogen? NO2 negative. The oxidation state of nitrogen is X. Oxidation state of oxygen is -2. Total, how many oxygen atoms do we have? 2. net charge -1, the value of X will come out to be +3 over here, right? So +3 is the oxidation state of this nitrogen right here, yeah? Okay, absolutely. Similarly, if I talk about Ki3, I need to calculate the oxidation state of iodine over here, yeah? Okay. See guys, potassium, it's a group first element, as you must be knowing, right? Potassium is a group first element. Group first elements, they show the oxidation state of +1, right? We have got only one potassium, right? Let's assume the oxidation state of iodine is X. There are some 3 iodine atoms multiplied by 3. Net charge 0. The value of X you'll be getting as -1/3. So -1/3 is the oxidation state of iodine over here, right? Okay. Let me know in the charts if every single thing is clear to everyone. So people, let me tell you, these were some basic rules which you need to remember, then only you'll be calculating the oxidation states of different elements in a given compound, right? Okay. Yeah. Now there are few more important things. What are those? Calculation of oxidation states from the structures. Calculation of oxidation states from the structures. Yeah. Why do we need to study this topic? Why do we need to know the structure of the compound in order to get the oxidation state of different elements in it, right? There is a reason for that, right? And what is that reason? What are the structures of different compounds which you need to remember, right? That's something which we'll be dealing with in the tomorrow's session, right? So you can just let me know in the charts if every single thing was clear till here, yeah? Okay. Let me know fast in the charts, guys. Is every single thing clear till here? Or if you'll be having any sort of doubt, do write your doubt, do mention your doubt properly in the chat box, right? Yes? Yes, Rishabh, oxidation states, it varies also, right? There are some elements which show the variable oxidation state as well. That's something which I'll teach also, right? This was the simple discussion in which I gave you the idea of actual oxidation state, right? Now in the next session, there are few exceptions, right? You need to know the structures of different compounds, then only you'll be able to calculate the oxidation state of different elements in those compounds, right? Okay, and once you are done with the oxidation state, this is a very important topic, right? Then your whole redox reaction chapter is going to be very easy for you, okay? I'm sure everything is clear to everyone, yeah? Right, people? Manit, I'm not getting what you are saying. Can you be a little more precise? All right. So at the end, the ones who have not joined into the actual long-term batches on Vedantu, right? Yes, the pro subscription batches, the actual batches on Vedantu apart from these YouTube sessions, this is something for you. Well, people, let me tell you, on 27th of September, our new batch for JEE 2023 is launching, right? We are launching a new batch for JEE 2023 on the actual Vedantu platform apart from the YouTube sessions, right? Okay? Right? In which you'll be getting trained by the teachers of your choice, number one, in your maths, in your physics, as well as chemistry, right? And there are 3 plans for it. You can take any one of the plans, right? Let me give the quick description of all these plans. First plan is what we call as a light plan, and this plan is valid for 2 years, right? It's a 2-year classroom program. This is the course fee for the 2-year classroom program, but Vedantu has kept an option. You can pay this much of amount in the form of EMI as well. Vedantu has kept an option as well, right? EMI option. And still, if you are new to Vedantu, you have no idea how the actual Vedantu classrooms look like. You can take this plan for a month. Check it out. If you think you are getting benefited from it, then only you can go for the 2-year classroom program, right? Okay, and what all things you are going to get over here? Definitely you'll be having the live interactive online classes with the teachers of your choice in all the 3 subjects, right? There will be absolutely regular test series analysis, right? Notes, and the best part is you get the study material, which is what we call as Tattva study material, which is one of the best across the country, trust me on that, right? And people doubt solving during the class itself, yeah? Similarly, we have got classic program. Why its cost is a little bit higher? Because one additional feature you get in this one, that is the doubt solving on mobile app, right? You get a mobile app in which in which you put on your doubts, you'll be getting your doubts cleared at that time only in all the subjects, right? And this is again valid for the 2 years. It's a 2-year classroom program, right? You can pay this much of amount in installments, monthly installments as well. And at the same time, if you're new to Vedantu, again I'm saying, right, you have no idea of how the actual Vedantu classrooms look like, I would suggest you guys to go for the 1-month pro subscription. Get the 1-month pro subscription. See if you're getting benefited, then go for it, right? Okay. And at the same time, why the plus pro subscription is why its price is a little more higher. Why is that? The reason is because you get the personalized mentor over here, right? In all the 3 subjects, physics, chemistry, as well as maths, right? You get the personalized mentor, guys, right? Rest all the features are similar. Yeah, and at the same time, again, I would suggest if you are new to Vedantu, do give it a try for a month. If you think you are getting benefited, then go for the 2-year classroom program. And I am giving you the guarantee you are going to get actually benefited from any of the plan which you are taking, right? Take the plan for a month at least and see if it is working for you. Definitely it will work for you. That's something which I'm providing the assurance, right? And people, while enrolling, do not forget to use this coupon code as WBPRO. By using this coupon code, you'll be getting some additional 10 to 20% off, right? And let me show you exactly how to get enrolled in the pro subscription, how to get enrolled in the batch, which is going to be launched on 27th of September. Let me show it to you exactly. Well, people, this is the video which you guys are currently watching, right? This is the video which you guys are currently watching. Yeah. Just drag the video a little down. There will be an option show more. Click on show more, right? Click on show more. Over here, you'll be getting the link for different things. Get KVPY SA 2021 crash course, which is just for 4K, right? You can take the crash course, right? And you can take the pro subscription. Let me find the link first of all. Well, I'm not getting the link. Where is it? Where is it? Where is it? Yeah. Subscribe to Vedantu Pro now. Click on this link. After clicking on this link, you need to select your plan. Any of the plan you need to select, right? If you are going for light, click on this. If you are going for classic, click on this. If you are going for plus, click on this. Let's assume I'm going to take the plus pro subscription, right? Let's assume I'm going to take the plus pro subscription, right? Well, you can take this pro subscription for a month. Over here, there's mentioned as try for a month or buy complete course. For example, I'm trying for a month. Right? After clicking on try for a month, you need to provide your phone number or email ID on which you get the OTP and enrollment will be done, right? And do not forget to use the coupon code, which is the WBPRO, I guess, or WSPRO. What was it exactly? WBPRO. You'll be getting some additional 10-20% off. And the ones who have not joined in to our Telegram groups, right? Do join the Telegram group of Enthuse channel, in which you get the regular updates of the sessions. And at the end, the ones who have not liked the video yet, please do like the video. Share the video with your friends and do not forget to subscribe to the channel as well. Yeah. Well, people, I'll see you guys tomorrow at the same time. Till then, you guys can take care. Bye-bye. God bless you all and love you all. Take care, guys. Bye-bye. Yes, Aisha, I'll be taking that. Yes.